Hey everyone, today we are talking about coal, but I just want to review really quickly. We had talked about trends in fossil fuels. We talked about what fossil fuels are, which you guys know they come from fossilized remains and they take millions of years. We know that the US uses more energy, surprise, surprise. Um, we talked about how energy is more prevalent, or energy use is more prevalent in developed countries because they have higher energy demands and they're not just gathering for themselves, they're not using those subsistence energy sources. We talked about how it takes more energy to dig in and find some of these resources after a while because we've depleted all of the easily, readily available resources. We reviewed second law of thermodynamics, which is what? Second law of thermodynamics says that as we use energy or as we transform it, its ability to do work decreases. And we see that with energy efficiency. So we did energy efficiency problems. We said energy efficiency is a ratio of the amount of energy you get out over the amount of energy you put in. And the energy at the bottom here, the energy you put in is always going to be the bigger number. Because as we put in energy, we're only going to get a certain amount of energy out that's going to be usable. It's going to be less than that because some of it's going to be lost as what? Will be lost as heat. So we're going to talk, we'll review electricity generation today. 40% of the energy consumed in the US is used to generate electricity. So electricity is a really big use of our resources. So the interesting thing with electricity is that it's clean when it's used. So we say that energy sources are clean if they don't emit any pollution. So if you think about it, you plug in your toaster. Is that emitting any pollution? No, okay? Or you go to plug in a radio or your cell phone. Is that doing anything? Is that causing any pollution in your house out of that electrical socket? No. So it's clean when you use it, but the problem is in order to produce it, it causes pollution, and we don't oftentimes think about that. So we need to burn the coal or burn the natural gas or burn the fossil fuels in order to create this electricity that you see. And we use lots of different fuels. So some power plants use natural gas, some of them use coal. There are a variety of different ways that we can produce electricity. So how is it generated? Okay, so the fuel is burned. That's step one. Whatever that fuel might be, whether it's coal, whether it's natural gas, it's going to end up being burned. So they're going to burn that resource, and you see over here we've got our little chimney stack. Okay, all of the exhaust gases. Here's our pollution, right? CO2 we know is produced from coal. Mercury, right? That gets in the little fishies. We know NOx, right? And SOx, SOx and nitrogen dioxide are also produced. So all of those things that we just learned about in that air pollution unit is going to be created at this point. Then it transfers this energy to steam. So we burn it. Here's our boiler. We're burning stuff and we're heating up water. Okay, and then this water right here gets turned into steam. And that steam turns this turbine. So this guy right here spins around and around and around. And it gets connected to a generator. And this generator basically spins around as well, but it's got an electromagnet in it. And this electromagnet is able to generate electricity. So you can generate electricity if you've got basically a magnet spinning. That's how they generate electricity. And then it goes out to the power lines. You'll notice down below, we have to then cool the water because our steam starts condensing and it's really hot water. And then we have to cool it again, okay? So we cool it and then it forms steam again. And this is where we get all of this cooling water being used. So we talked about power plants using a lot of water. This is why. It's because they use it to cool their equipment. If they kept this water hot the whole way through, it wouldn't actually be good for their equipment. You have to keep it at a lower temperature, so they end up cooling it. We talked a little bit about thermal pollution, this idea that this water, if it gets released into a stream, it could actually raise the temperature of that stream and then be problematic for the organisms that live in there. So then the energy is transported to what we call kind of the electrical grid, and that's just a series of towers that distribute it to all of your homes. And you guys have seen all these little towers. It's called the grid. You don't really, this is not something I see on the AP exam a lot. Like, I've never seen them ask about an electrical grid, but this is what happens. You can see in this picture over here, you can see a picture of the United States and all of the power plants and the lights. So these are all the lights. This is just the electricity. So it's a good indicator of where we're getting power to. And this is when there was a huge blackout in the Northeast. This was in 2003. So a huge power plant failed, and it caused this entire region to not have electricity. So that entire part of the electrical grid did not have electricity. All right, I'm gonna have you put an X on this one. You can write it down, but I've never actually seen it on the AP exam. It was in our textbook, and that's why I included it, but I'll talk about it anyway. So the combined cycle power plant. So how do we increase the efficiency of electrical power plants? So typically what we can do is we can use them for more than one purpose, okay? The combined cycle power plant has 2 turbines instead of 1. So you'll see that one is run by gas and one is powered by steam, okay? So over here, the steam one, we're still using gas to make the steam, but we're also using gas or oil to turn another turbine. So we've got 2 turbines turning at once, and we can increase the amount of electricity produced, which is good, except for the fact that, well, we're still using gasoline, right? We're still using fossil fuels. The better option, which I'm going to have you put a star by because College Board always likes to ask about this. There's usually one question on cogeneration. To cogenerate means to generate together. So this is when we use fuel to generate electricity and to make heat. So we know we're already making heat with these power plants. So why not use the heat to do something useful, right? We are creating all of this heat with this steam. Why not use it to do something useful? So what they actually use it for is they use it to heat homes. So in a normal system, down here, we have our fuel. We convert it to electricity. We only use the electricity, so it's only 50% efficient because we're only using the electricity. The heat is just lost to the environment. We cool it down. We don't use the heat for anything, okay? In cogeneration, we end up taking this fuel, we make power and heat, and we use both of those, okay? So in the system over here, what they're actually showing you is we have a separate system for heating, right? So we're using energy to create heat in a furnace or a boiler rather than using the energy or the heat from the power plant. So cogeneration, just using the heat we already have from that power plant, and instead of having it be lost to the atmosphere or to water, we're using it to actually heat homes. So this can be a very beneficial way to help increase the efficiency of power plants. Now we're going to do coal, and then I will stop, okay? So take a second. What do you know about coal? Do you know where we get it? Can you think of what it's used for? Do you hear anything about it in the news? I'm going to ask you all of these questions at the beginning of each one of these different fossil fuels. I don't expect you to know a ton, okay? Most people tell me like, oh, coal, it looks like this, Santa Claus brings it. I ask them, where do we get it, right? Most people will tell me, oh, we get it underground, we have to dig for it, okay? What do we use it for? Oh, well, we use it to make electricity. You might know that we used it in trains. Have you heard anything in the news? Some people may have not heard anything. So, coal, most abundant, okay, meaning widespread. It's pretty common. It's also the dirtiest, which is not so great. If you pick up a piece of coal with your fingers, like if I go back here, If you pick up a piece of this coal, your fingers will be all black, okay? Which is a problem because when you burn it, all of that black stuff goes in the air. If you've ever seen a train, or pictures of a train running and they're burning coal, it's just these black billowing clouds of smoke coming out of that train engine. So coal is most abundant and it's the dirtiest fuel. It comes from something called peat. And you can see here, this guy is shoveling out some peat. So what the heck is peat? You can buy peat moss for your garden, but peat is formed when there's basically a swampy area and it's this carbon rich kind of, it looks kind of like dirt. So peat, it forms in swamps or bogs, okay, so waterlogged areas. And when these plants, these like marsh plants die, this is not a bog itself, but it used to be. But when all these plants die, they decompose. And remember we said there's not really a lot of oxygen, so they decompose anaerobically and they produce this peat. It's got a lot of carbon in it from those decaying animals. Here's some peat. And people will use this peat and you can actually like burn it and use it for fuel. So they'll dig it up in certain places if they can find it. But remember, it takes millions of years to form, so it's not found everywhere. If we look at this graph down here, we can see where coal is found. Most of it is in the US. And then we got Russia, China, India, Australia. Most of it's in the United States. And if you've done any history lessons, you might have talked in history class about coal miners or people mining coal. We have actually a pretty rich history of mining in Wisconsin as well, and you may have talked about that sometime like in middle school or elementary school. So top 3 countries with largest coal reserves, US, Russia, and China. This is one where they like to have the question where they have like the map of the world. So they'll have like a globe and they'll have a map and they'll put like a bunch of stars with like A, B, C, and they'll ask you one like, oh, where would you expect coal to be the most abundant? And you would pick like the United States. So they like to do that kind of stuff with these types of information. So if we take a look at the United States, here's where we have coal. Okay, now remember, this is where we had coal initially. Some of this might be mined out, but we've got a lot of coal here in the kind of northeast, but in the eastern part. Got some coal here, and then out west, and then a little bit in Alaska. So again, it's kind of random. It's wherever there was these really swampy regions that ended up burying all of these plants and animals, and then they turned into coal. So we're going to look at what happens to coal or how it forms precisely today. I'll give you a really quick overview. I'm going to be the first to tell you that this is not my favorite topic and I don't know very much about it. And I had to Google lots of things before I taught this to you. So I think it's not my favorite that they ask you to know these different names, which you're going to look at on your worksheet today. But they do. Okay. All right. So anyways, here is what happens. Okay. So vegetation dies, it's buried under anaerobic conditions, right? That's in swamps where there's not a lot of water. Okay. This forms peat when it starts decomposing. The peat is compressed between sediment layers, so dirt layers, and it forms something called lignite. It's compressed further and it forms subbituminous coal and bituminous coal. And then after that, then it forms anthracite. So what are all these big words? These are all different stages of coal when it's forming. Okay, I didn't have you write anything down. You have a worksheet that you're going to do on this. But if you want to take a second and just write the order of them down on your sheet, you can if you would like. Alrighty, advantages and disadvantages. So advantages of coal. Lots of energy can be taken from it. It's energy dense, it's plentiful, easy to find. We don't have to process it. So refining means processing it. So do I have to put it through and wash it? Do I have to combine it with something else before we can burn it? All of those little things. So it's pretty easy to use, and that's why we've been using it for quite a long time. Disadvantages, however, mining, okay? We talked about all of the consequences from mining. We talked about acid mine drainage. We talked about habitat loss. Okay, we talked about all of the health effects. So mining, you have to mine it. That's a problem. Releases a lot of pollutants into the air. What are those pollutants? Sulfur, mercury, lead, arsenic, right? All of those air pollutants that we just learned about. Makes a lot of ash. And it also produces more CO2 than oil or natural gas. And remember, CO2 is that greenhouse gas that's going to cause our Earth to heat up. So these are advantages and disadvantages of coal. I know I talked through that fast, so go ahead and pause it and you can write them down. We're going to do a worksheet today. You just have to do a little reading and answer some questions on coal, just to get a better idea of how it forms and what are the different types. Okay?